Hello, and welcome to this video. Today we're taking a journey back in time to an era when an important local railway was gearing up for a complete transformation. We're talking about one of the UK's earliest electrified lines, the route between Liverpool, Southport and Ormskirk. The year is 1940. The Liverpool, Southport and Ormskirk lines, first electrified by the Lancashire and Yorkshire Railway back in 1904, was a successful system. But many of its trains were getting old, 36 years old to be precise. They needed to be replaced, and the London, Midland and Scottish Railway, or LMS, stepped up with a much needed replacement programme. This project was huge, building over 152 welded steel vehicles with electrical equipment valued at £250,000. This wasn't just a refresh, it was a complete revolution in travel and operation for the line. The LMS needed to make a flexible fleet to handle everything from rush hour crowds to off-peak services. The new trains were built in two main types of units. 3-car trains. There were 34 of these. Each set consisted of a driving motor coach, a trailer and a driving trailer. 2-coach units. A further 25 of these were built, consisting of a driving motor coach and a standard trailer. This combination of 2- and 3-car sets was ingenious. It allowed the railway to form trains of any coach number from 2 upwards. In the rush hours, they'd combine a 2- and 3-car set to make a 5-coach train, and sometimes even a 6-coach train, using 2 of the 3-car sets. The non-driving 2-coach units even had a window and bell communication to the motor coach cab to help the crew when shunting and making up these complex trains. These new trains weren't just about capacity, they were about speed and efficiency. The average distance between the stations on the normal stopping services was about 1.23 miles. The target, a scheduled speed of 30 miles an hour, even with a fully loaded train and a 20-second stop at every intermediate station. This represented a significant upgrade, cutting the overall running time by about 10%. Let's talk acceleration. Starting from rest, the fully loaded 5-coach trains could accelerate at approximately 1.6 miles per hour per second, and the heavier 6-coach trains at 1.4 miles per hour per second. That's a powerful start. Crucially, all the new trains were capable of a top speed of 70 miles an hour when fully loaded, allowing for faster running on express routes and through services. Now, let's dive under the skin. The electrical wizardry was supplied by the English Electric Company Limited. The man setting the requirements was Mr. Charles E. Fairbairn, the LMS's Deputy Chief Mechanical Engineer and Electrical Engineer. Each motor coach was a powerhouse, equipped with 4 no-suspended traction motors, driving the axles through heavy spare gearing. 1 hour rating 234 horsepower per motor, continuous rating 184 horsepower per motor. The motors drew power from the 600-volt third rail. The control system used a highly advanced series parallel and field tap control system with bridge transition between series and parallel connection. Acceleration was finally managed by a balanced armature type of current limit relay. This was a big improvement over older plunger type relays because it wasn't affected by vibration or train movement. If a motor experienced an overload, sophisticated interlocks ensured the line contactors opened in sequence, protecting the equipment. For flexibility, the drivers could even isolate a faulty 2-motor equipment in any train up to a 6-car length, using a simple push button in the cab. The rolling stock was built at the LMS's Derby Works. The Chief Mechanical Engineer, Mr. William Stanier, aimed for a dual goal, lightweight and rigidity. To achieve this, the entire body structure was constructed using welded steel from the underframe up, a technique that was highly advanced for the time. Even the interior partitions were made from a light, pressed steel framing, arc welded together. The floors were built for comfort and quiet, made of linoleum laid on felt and cork, supported by galvanized steel sheeting welded to the underframe. To prevent corrosion, especially in the humid seaside climate, spaces were intentionally left open between the inner and outer panels of the body sides and roof. This allowed air to circulate and minimize the difference in temperature and humidity, acting as a crucial preventative measure. The foundation of the ride quality was the bogie design. a development of the LMS's standard carriage bogie. The driving bogies used a sturdy plate frame type with wheels spread over an 8 foot 6 inches base. They made a significant weight saving compared to the old stock by using 36-inch tyre disc wheels instead of the old 43-inch wheels, which reduced unsprung weight, a key factor for a smoother ride. In another modern touch, they employed roller bearings for the axles, reducing friction and maintenance. Trailer bogies used Skefco roller bearing axle boxes, whilst the driving bogies featured Timken tapered roller bearings. These advanced bearing designs were even evolved to be easily serviced and turned on modern wheel lathes, demonstrating forward-thinking maintenance planning. The Timken bearings, for instance, ran in an oil bath, designed to hold enough lubricant for 6 months of operation without needing a top-up. Inside the coaches, passengers were greeted with a clean, well-thought-out design. Entry was through wide, 3 foot 9 inch doorways, with air-operated double doors that slid into the walls. Control was managed by the guard, but passengers could open the doors themselves with a push button once the guard activated a master switch. A nice touch of convenience. Third class featured plywood panels veneered with sapele or paldo. Seating was arranged for 3 persons on one side and 2 on the other side of the gangway, upholstered in a green uncut moquette. First class offered more luxury, with armrests, upholstery in fawn and brown moquette, and a mottled carpet over the linoleum floor. Instead of advertising frames, first class compartments featured photographs on the walls. All classes benefited from the electric heaters positioned below the seats and 60-watt lighting connected in circuits of 5 lamps on a 600-volt supply. The driver's cabs were also made with safety and comfort in mind, including an upholstered seat that automatically swung out of the way, and an air-operated windscreen wiper. A few other key systems kept these trains running safely and smoothly. The trains used Westinghouse electro-pneumatic braking. This gave the driver a self-lapping brake controller and a gauge to indicate the brake cylinder pressure, allowing for precise control. Compressed air was supplied by a powerful 2-cylinder air compressor, needed for the brakes, the electro-pneumatic control gear, and the door operation. A clever synchronizing wire ensured that the compressors on multiple coaches ran simultaneously. Low tension supply. For the control circuits, a reliable 52-volt supply was provided by a motor generator set, working with an alkaline battery of 36 cells. This setup was so stable it didn't even need a voltage regulator. Finally, there was a crucial detail reflecting the period: wartime measures. As these trains were rolled out of the shops, they were equipped to meet the lighting regulations of the Ministry of Transport, with shades and modifications to prevent light from escaping during the blackout. This certainly wasn't the ideal time to introduce a new fleet. This recently delivered motor coach has suffered serious front-end damage, whilst this one has shrapnel damage and broken windows. One unlucky coach, a centre trailer, number 29576, survived less than a year before being destroyed in an air raid. The new LMS trains for the Liverpool, Southport and Ormskirk line represented a major step forward in electric railway traction. From the powerful 235 horsepower motors and the advanced electrical control gear to the lightweight steel bodies and the comfortable modern interiors, they were a testament to British engineering prowess. They didn't just replace the old rolling stock, they set a new standard for speed, efficiency and passenger comfort on one of the country's most vital commuter lines. These trains were destined to provide a faithful service for 40 years. A 2-coach unit was to be preserved and is currently undergoing restoration by the Class 502 Preservation Trust. That's all for our look at this revolutionary project. Many thanks for watching.